Every new idea, skill, or memory changes how brain cells communicate and connect with one another. In this video, we'll explore how learning happens in the brain, uncovering the biological processes that allow us to understand, remember, and grow through experience. 1. What actually happens inside the brain when we learn something new? When we learn something new, the brain changes its structure and activity. Learning happens as brain cells, called neurons, become active and start communicating with one another in new ways. This activity forms patterns that represent information, skills, or experiences. With continued learning and practice, they become stronger and more stable, allowing the brain to store and retrieve information later. 2. How do neurons communicate with each other? And why is this communication essential for learning? When one neuron is activated, it sends a signal across a small gap called a synapse to another neuron. Learning depends on how efficiently and frequently neurons send signals to each other. The more successful the communication, the stronger the learning becomes. 3. What is neuroplasticity, and how does it enable the brain to form new skills and memories? Neuroplasticity is the brain's ability to change and adapt throughout life. It allows the brain to form new connections, strengthen existing ones, and sometimes weaken connections that are no longer useful. Thanks to neuroplasticity, people can learn new languages, skills, and ideas at any age. Every time learning occurs, the brain physically changes, making neuroplasticity the foundation of learning and memory. 4. How do synapses strengthen or weaken during the learning process? And what does this mean for long-term memory? When neurons communicate frequently, the synapses between them become stronger. This process is often summarized as neurons that fire together, wire together. Stronger synapses make signals travel more easily, which helps form long-term memories. This explains why information that is not reviewed or practiced is often forgotten. 5. Why is repetition important for creating stable neural pathways in the brain? Repetition gives the brain multiple chances to activate the same neural pathways. Each repetition strengthens the connections between neurons, making the pathway faster and more reliable. Skills like reading, playing an instrument, or solving math problems become easier over time because repetition builds stable neural networks. 6. How do emotions influence learning, and what role does the amygdala play in memory formation? Emotions have a powerful effect on learning. The amygdala, a brain structure involved in emotional processing, helps determine what information is important enough to remember. Positive emotions like curiosity and excitement can enhance learning by increasing attention and motivation. Strong negative emotions, such as fear or stress, can interfere with learning by disrupting focus and memory formation. 7. What is the difference between short-term memory and long-term memory in terms of brain function? Short-term memory, also called working memory, holds information briefly while we use it, such as remembering a phone number or following instructions. Long-term memory stores information for extended periods, sometimes for life. Moving information from short-term to long-term memory requires attention, understanding, and repetition. Different brain areas work together to make this transfer possible. 8. How does sleep contribute to consolidating new information and strengthening learned material? Sleep plays a critical role in learning. During sleep, the brain replays and organizes information learned during the day. This process is called memory consolidation. Adequate sleep helps strengthen neural connections and integrate new knowledge with existing memories. 9. What factors can enhance or accelerate learning at the neurological level, such as attention, nutrition, or physical activity? Several factors support brain-based learning. Focused attention helps activate learning-related brain networks. Good nutrition provides energy and building blocks for brain cells. Physical activity increases blood flow and supports brain health. Together, these factors create conditions where learning can happen more efficiently. 10. How can understanding the brain's learning mechanisms help students create more effective study strategies? When students understand how the brain learns, they can study smarter. Strategies like spaced repetition, active recall, meaningful practice, and adequate rest align with how neural connections are formed and strengthened. Learning is not just about effort, it's about how the brain changes with experience. By understanding how learning happens in the brain, students and educators can create environments and strategies that help every learner reach their full potential. Thanks for watching.